Hello, this is an overview of the supervisor deployed for the scene assembly line of the factory I/O library. In this moment, you're seeing the correct functioning of the plant, where all of its actuators and sensors are working. Please notice that there is movement in the axis X, graph Z, 2 bands, 3 diffuse sensors, and only in this case we're using the green button. So how can we synthesize a supervisor for this plant? Well, first of all, as you could see, there is a lot of actuators and sensors. So in this case, we opted to make not one monolithic supervisor, but 5 distributed supervisors to ensure that the code is not too long to be processed. So most of the actuators, for example, the lead converters, are modeled as a 2-state and 2 transitions automaton. And to each of these, one or more specifications are also modeled. For example, in this case, for the leads conveyor, there is this specification, which name is start leads conveyor, which ensures that the conveyor doesn't start his work until the event start on happen. In this case, it's uncontrollable, and in the real world is related to the green button to start the plant. So this is not the case for all of the actuators. For example, you can see here that we also model the axis Z and X as a 4-state to ensure that the movement is completely done until it can change here and here, and of course its requirement, which includes axis X, Z, and the grab process. So to begin, we need to define the dictionary, which relates all the events with a variable, a real physical instrument, sensor, or actuator. In case you need a fully nature version edge, it is also described here. A mask that relates the output 12 and output 13 with the inputs 10 and 11. After we define and model every automaton, then after aggregating the models, we synthesize a supervisor according to Professor Kai's procedure with the TCT software. In this case, we know that because of the groups we made on the models and their specifications, no uncontrollable events are shared by the groups, and therefore there will be no conflict. This is not the same case about controllable events. So you will see in the SD code how it is solved. So we run the file. You get here the SD code. Discovered. You can see all the files, the TCT software, and here we can take a look of a little description of every one of the automata. 5 supervisors and 5 plants. Just notice that supervisor 2, supervisor 3 are too large to do a manual inspection because of the large number of transitions. And imagine how big it will be if we just make a monolith supervisor. We generate an image of each one of the automaton of the supervisors. As you can see, supervisor 5, 4, and 1 have the same structure. Are pretty simple, but supervisor 2 and 3 are really large. This happened because supervisor 2 is the one corresponding to the clamp, the axis Z, and the axis X with the grab. And the supervisor number 3 has the clamp in the base, also the grab, and also the X axis. So how this is managed in the structured text code. So first of all, we have a random number generation function block, then the variable blocks, internal and externals, the definition of the falling edge, and then for each one of the supervisors, which a number is assigned, all his uncontrollable transitions. Then we have a case statement to decide to choose all the controllable events in between the active function of each state. Supervisor number 1, number 0, 1 here, and 2, and so forth. Notice that in some cases there is an array here with the prefix G. This happens when more than one supervisor wants to activate a controllable event. In this case, each one make a guess, and if all of them agree to activate the same event, it will happen. In other case, it will just wait until the next cycle and hopefully activate the event, as you can see shows here. After that, there is only the controllable level transitions to update the state of each one of the supervisors, and at the end the mask. Now we're gonna take a look of how it works. So I'm gonna choose assembly line, update program. Let us go to the same folder. Assembly line just generated. Open and upload. While it charges, you see that it is connected by a TCP/IP connection, and that all the inputs and outputs are related. Now we start. Let's just play here and start the process.